Hello once again, welcome to channel. Okay, so just in my previous video we have discussed about for Fermat's last theorem for the proof of p equal to 3. So if at all a plus p plus b power b is equal to c power b, if at all a cube plus b cube is equal to c cube, we know from Fermat's split theorem that actually it is like c plus 3k1. Okay, so we also discussed that if c is multiple of 3, then we end up in infinite descent. Okay, so in this video what we are going to do is that if c is not a multiple of 3, so then we will try to prove that there are no integers. Okay, so once again c cube is equal to a plus b whole square minus 3ab. A plus b is equal to c plus 3k1, so c cube is equal to c plus 3k1 whole square minus 3ab. Okay, so if c is not a multiple of 3, then this is not multiple of 3. What this means is that these two terms, they are co-primes. That means that there is no common factor between this term and this term. If c is multiple of 3, they are not co-primes. So we have proven that if c is multiple of 3, we don't get any positive integer solutions. What we are going to prove now is that if c is not a multiple of 3, these two are co-primes. So let us assume that c is part of 2 primes other than 3. Okay, p1 and p2 not equal to 3. So since it is like p1 cube, p2 cube, c plus 3k1 and 3k1 whole square minus 3ab, these two are also co-prime. There is no common factor. That means that c plus 3k1 must be p1 cube and c plus 3k1 whole square minus 3ab must be p2 cube. Because when you cube it, the factors remain same. The factors will be like p1 and p2. Okay. What we are going to, when you cube it, the factors gets cubed. Okay. So what this means is that if that c cube is equal to a plus b into something which are co-primes, then so a plus b must be p1 cube and a plus b whole square minus 3ab must be p2 cube. That is because they are the co-primes, so individually they must be cubes. Okay. What this also means that c cannot be a multiple. C cannot be just a prime number. It should be part of 2 prime numbers. Okay. So yeah. So once we have this equation, we are trying to see whether we can have some sense, some positive integers out of this. Okay. So c plus tk1 is pkb. Sorry, p1 cube. So p1 power 6 minus 3ab is equal to p2 cube. This implies 3ab is equal to p1 power 6 minus p2 cube. Again, we need to c is equal to p1 p2, a plus b is equal to p1 p2 plus 3k1. Okay, so this we need to keep this in mind. Okay, now p1 power 6 minus 3ab is p2 cube, 3ab is equal to p1 power 6 minus p2 cube. What this means is that it should be like p1 square minus p2. This is like a cube minus b cube once again. So p1 square minus p2, we can write this as p1 square minus p2 whole square plus 3p1 square p2. It is 3. So now, see this, if let us assume that P1 square minus P2 is not 3 multiple. What this means that this is not 3 multiple, this is not 3 multiple. So the left hand side is actually 3 into AB. So what this means is that P1 square minus P2 must be something like 3 into 3 multiple. Okay? If it is not 3 multiple, then this is not 3 multiple, that is not 3 multiple, because that's square and plus 3 something. 3 into something. So this term is not 3 multiple, so 3 into something plus 3 not multiple is not multiple of whole thing. So something like this, 3x plus y is not a 3 multiple if y is also not 3 multiple. Okay? When I add two numbers, if one is a 3 multiple, the addition should be 3 multiple to have whole thing as a 3 multiple. This is the basics, arithmetic. Okay? So if this is not 3 multiple, this is also not 3 multiple, but this is a 3 multiple. So whole term is not 3 multiple. But left hand side is actually 3AB. So P1 square P2 is equal to 3R. Okay? So what this means is that 3AB equal to 3R 9R square minus 3AB minus 3 plus 3 P1 square P2. Again. Okay? So now 3 gets cancelled. AB equal to 3 is common here. So 3 into 3R square plus P1 square P2. What this means is that one of the AB is 3 multiple. Previous, we assumed that 3 is a 3 multiple. When C is a 3 multiple, A and B are not 3 multiples. Okay? That is not possible. If C is a 3 multiple, we proved that. Now, when you started with C is not a 3 multiple, we ended up one of the ABs are 3 multiple. Okay? So now let us assume that A is equal to 3A1. Now the equation of C cube is equal to A cube plus B cube. We can simply write it as A cube is equal to C cube minus B cube. Now C A equal to 3A1. So 27 A1 cube is equal to C minus B whole square plus 3CB. Okay, so what this means is that we have when A cube plus B cube is equal to C cube, we end up one of the A, B and C must be 3 multiple. Otherwise, this equation is not possible. Okay, so yeah, if let us assume that A is 3 multiple now, C cube is equal to A cube plus B cube, so A cube is equal to this guy. And then we have 27 A cube minus C minus B. Okay, once again. 27 A1 cube, okay, is equal to C minus B. Let us assume that C minus B whole square plus 3CB. Okay, so when we already know that A plus B minus C is actually 3 multiple. So when we end up in A is a 3 multiple, C minus B is also 3 multiple. So C minus B will be, this implies C minus B will be A minus 3K1. So 27 A1 cube, A minus 3K1, A is again, A is what? 3A1. So C minus B is equal to 3 into A1 minus K1. So 27 A1 cube is 3 into A1 minus K1, C minus B whole square, 9 into A1 minus K1 whole square plus 3CB. Yeah. So what? So 3 9A cube, 9A1 cube equal to A1 minus K1 again there will be like 3 into a1 minus k1 whole square plus cb. Now, okay, so there will be 3, so it will be like 3 into this one. So it will be like 3a1 cube now. 3a1 cube is equal to a1 minus k1 into something. Okay, so now again we end up in 3a1 cube a1 minus k1. Now we ended up in similar thing when c is 3 multiple. Okay, so 3a1 cube should be divisible by a1 minus k1. Now a1 minus k1, let us assume 9, I mean, if suppose they should have a common factor with, let us take a1 is equal to, again something like p3 and p4. So pa1 and pa2. So a1 minus k1 is pa1, okay. So, okay, before even going there, a1 minus k1, because the left hand side, the right hand side is what? 3 into a1 minus k1 whole square plus cb. Once again, we need to understand that c and b are not multiples of 3 when a is multiple of 3, because a is co-primes. So what this means that this is not a 3 multiple. What this also means that a1 minus k1 must be 3 into r1. Okay, so yeah, so 3 into 3r1 plus k1 whole cube by a1 minus k1, 3r1. That's it. Okay, 3r1 plus k1 should have r1 as a common factor. Once again, we hit upon the previous, when c is multiple of 3, that k1 and r1 should have a common factor. So when k1 and r1 should have a common factor, let us take k2 or p2 something. Okay, so p4. So k1 is equal to p4 k2, r1 is equal to p4 r2. Okay, again we go into the infinite descent. So what this means is that you have a cube plus b cube is equal to c cube. Then one of them should be multiple of 3. If any of them is multiple of 3, we end up upon infinite descent. Therefore, we don't have any integer solutions. As simple as that. Because we started with Feynman's little theorem. So yeah. Okay. I hope you understand it. And then because I'm going to similarly prove that a power 5 plus b power 5 is not equal to c power 5. Similarly, a power 7 for all primes actually. So we can actually extend this proof for all primes. Okay, the formula is a little different. It will not be like, for example, if we have 5, right? If I have 5, it will be like 5k1 here. Okay, so yeah, it will be 5k1, and then alright, so c power 5 is equal to a power 5 plus b power 5, if at all. Again, once again, it is a factor of a plus b. It will be like a plus b power 4 minus 5ab into, I think, a square plus ab plus b square. Okay? So a plus b is equal to 5c plus 5k1. So c plus 5k1 power 5 by c plus 5k1 equal to c plus 5k1 whole power 4 minus 5ab. Again, here it is like you can write it as a square plus b minus ab. Alright, we start with C is multiple of 5. Okay, so C is equal to, let us take 5C1. So 5C1 plus 5K1 power 5 by C plus 5K1. 5C1. Sorry, 5 into C1 plus K1. C plus 5K1. So 5 into C1 plus K1 minus 5AB. Again A plus B whole square is A plus B is equal to C plus 5K1. C is 5C1. Okay, so since C is a multiple of 5, A and B cannot be multiple of 5. Okay, so this whole term, if I take 5 out, so it will be like 5 cube C1 plus K1 power 4 minus AB 25 C1 plus K1 whole square plus A square. Okay, so it will be like 5 power 5 C1 plus K1 power 5 by 5 into C1 plus K1 5 power 4 C1 power 4. Yeah, I mean we are going to prove in a similar fashion. Okay, so I'll try to prove it in my next video. Thank you very much.